Hello students, today we're going to solve problem number 128 from chapter 6. So here we have double inclined plane problem, which is shown below in the picture. The coefficient of friction on the left surface is 0.3 and on the right surface is 0.16. Now we have to calculate acceleration of the system. The mass is given and also the angle is given for both sides. Now let me draw the picture and write down all the forces that we have for the left and right surfaces. Okay, so basically we have right side plane and side plane. Okay, so this angle is 37 degree. That one is 53 degrees. Okay, then what do we have here? We have, let's just make it a box, okay, to make it more simple. Then here we have another box. Okay, so then we have here the rope. Okay, now the right side I will call it M2, which is equal to 15 kilogram, and the left side I call it M1, which is equal to 10 kilogram. Now we also know that mu2, coefficient of kinetic friction on the right side, is equal to 0.16, and on the right side, on the left side, the coefficient of the friction is 0.3. Okay, now let's draw a free body diagram for the right side, also for the left side. So what we have, first of all, we have a weight, which is the weight is equal M2G, right? Then what we have a tension. Call it tension, right? Then what else we have? We have friction. Now we assume that by looking at this picture, we are assuming that the right side is more mass, 15 kilogram, and plus it has less friction. So we assume that whole system actually will be moving clockwise direction. So we assume that acceleration will be pointing in this direction, and whatever is in this direction, we will call it positive. Okay. Now, what else? We also have a normal force. We also have a normal force, which is perpendicular to the surface. Call it normal force 2. Then what else? Now, since the weight is pointing at a certain angle, which is 53 degree, that means it can be resolved into two components. Okay, so the first component of M2G will be this one will be M2G sine 53 degrees. Okay, sorry guys, this will be cosine 53 degrees. M2G cos 53 degrees, and that one will be M2G sine 53 degrees. Okay, what else? We also have a friction, so I call this one the friction. I call this one friction 2. Okay, now we are finished with the box, which is on the right side. Now let's draw the free body diagram for the left side box. So we have a tension, we have a friction, so call it friction 1. Then we have a normal force the normal force is perpendicular to the surface. Call it normal force 1. What else? So we have a weight. The weight, which is weight 1, which is m1g. Now, since weight is directed at a certain angle, this theta will be the same as this 37 degree. So if it's 37 degrees, this angle, then we can say that this weight, which will be m1g cos 37 degrees. Then we have this force, which will be m1g sine 37 degrees. Okay, now so far we have finished writing down all the components of the forces. Okay, now now let's write down equation for the right side and also for the left side. Now, since the object is moving, we can say that for the right side, I'll call it I'll call it 2. Let's write down the equation. So first of all, we have to start with the sum of the forces in x direction is equal m2a, right? Now, what is the sum of the forces in x direction? So we call this one x, this direction x, this will be our y. So that means in x direction for the right side box, we can say that m2g sine 53 degrees, negative tension because pointing opposite direction, minus friction 2, and that is equal to m2a. Now, what about the sum of the forces in y direction for the right side box? Is equal, now since the box is not moving in y direction, so it's equal to 0. So therefore we can say that normal force 2 minus m2g cos 53 degrees, which is equal to 0. So that means normal force is equal to m2g cos 53 degrees. Okay. Now what about the friction? The friction, now friction 2 is equal mu2 normal force, right? Or we can say that friction 2 is equal to mu2, since normal force 2 is equal m2g cos 53 degrees. Okay. Okay, so that means let's write down full equation for the right side by substituting everything on its place. So that means we're going to have m2g sine 53 degrees minus tension. Now friction 2 is equal to mu2 m2g cosine 53 degrees is equal to m2a. So this will be our equation 2, which is dedicated for the second box, which is on the right side. Now let's write down equation for the left side. Okay, for the left side, what we're going to have. So for the left side, let's write down that sum of the forces in x directions is equal to m1a, right? Now what is the sum of the forces on the left direction, on the left box? So we're going to have tension, which is in a positive x, minus friction 1, then minus m1g sine 37 degrees, right? Is there anything left? Okay, which is equal to m1a, right? Now, then what about the sum of the forces in y direction? Now, since it's not moving in y direction, which means it's equal to 0, that means we have a normal force 1 minus m1g cosine 37 degrees, which is equal to 0. And therefore we can say that normal force 1 is equal simply m1g cosine 37 degrees. What about the friction? Now the friction 1 is equal mu1 times normal force, or mu1 normal force 1 is equal to m1g cosine 37 degrees. And if you want to put everything on its place, then we're going to have the tension minus friction 1 is mu1 m1g cosine 37 degrees minus m1g sine 37 degrees is equal m1a. Okay, so this is our first equation. Now, okay, so in this case we have two equations and two unknowns probably. Yes, so the first thing that you have to do, I think you want to cancel the tensions. So if you add these two equations, then you will end up canceling the tension. Okay, so if you add these two equations, then what will we get? We will get that m2g sine 53 degrees minus mu2 m2g cosine 53 degrees, then minus mu1 m1g cosine 37 degrees minus m1g sine 37 degrees, which is equal to m2a plus m1a. Okay, so from here you can say that the whole things, let me write it down here, m2g sine 53 degrees minus mu2 m2g cosine 53 degrees minus mu1 m1g cosine 37 degrees minus m1g sine 37 degrees, right? Then divided to the whole m1 plus m2, which is will give us our acceleration. So that's it. So when you plug the numbers, you will get your acceleration. And you can obviously also find the tension by substituting the acceleration and other values either in the first equation or in the second equation.